This example says, write an equation for the inverse function and then state the domain and range of f and f inverse. Our function is f of x equals cube root of 7x minus 3. There's a three-step process we can go through for finding the inverse of a function. So let me write f of x equals cube root of 7x minus 3. And the first step in the three-step process is to change this f of x to y. It's a little bit easier to work with the symbols when you have just the y. The next step is to switch the x and the y. And this step right here is sort of the crux of why this method works, because inverse functions have the x and y values switched. So by us switching them, we're now creating the inverse function. The final step in this process is that we now want to solve for y. We want to get y by itself on one side. So I've got to get rid of all this other stuff. I've got to get rid of this cube root, the 7, and the minus 3. The first thing we're going to get rid of is the cube root. So we're going to get rid of that cube root by doing the opposite of cube root, which is cubing. So x cubed on the left, and on the right, I am going to cube this whole side. So nothing to do on the left. On the right, the cube root and the cube cancel each other out. So we're left with 7y minus 3. So we're still working to try to get that y by itself. So then I'm going to get rid of this minus 3 by doing the opposite of subtracting 3, and that's adding 3. You're going to x cubed plus 3 on the left, and on the right, the minus 3 and plus 3 becomes 0, and it cancels out from that side. We're still trying to get y by itself, so we're going to divide both sides by 7, and that gives me y equals x cubed plus 3 over 7. And now that we've gotten y by itself on one side, we have the inverse function. So I'm going to write that as f inverse of x is x cubed plus 3 over 7. So we found the inverse function. So let's go to the next part. The next part says the domain of f is, so looking at the original function, I want to put this function in a category. The categories you should be thinking about are polynomial, rational, and root. Because this one has a radical, this is a root function. And once you decide that it's a root function, you want to pay attention to the index on that radical, because you find the domain differently based on whether that index is even or odd. So because this is an odd index, what we know is that the domain of odd index radicals is all real numbers. So the domain of f is negative infinity to infinity. Now that we found the domain of f, we've also found the range of f inverse. Remember, the x's and the y's get switched. So because we know the domain of f, we have the range of f inverse. So I'm going to skip over finding the range for the moment, and let's go to finding the domain of f inverse. This is our definition of f inverse, and I want to put this function in a category. Remember, our categories are polynomial, rational, and root. You can see that the root is gone. But we do have a fraction. Even though we have a fraction, there's no variable in the denominator, so this is not a rational function. This is going to be in the category of polynomial because our power is one of the nice powers. And what we know about polynomial functions, about their domain, is that they have a domain of all real numbers or negative infinity to infinity. So the domain of the inverse is negative infinity to infinity. And like I said a moment ago, the x's and the y's get switched with these functions. So this is going to tell me that my range of f is negative infinity to infinity. Thank you for checking out my videos. Have a great day.